In today's video, we are going to take a look at step 3. I can apply properties of exponents. We will talk about this second portion of the title later on in another video. Right now, we're just going to focus on properties of exponents. You may have practiced with some of these properties of exponents, the rules. You may have used these in the past, but just to make sure we're all on the same page, we're going to go through each one again and then apply them to a bunch of examples to make sure that you're feeling very comfortable working with exponents. In order to simplify an expression, because that's the kind of verbiage you're going to see on a test or a standardized test, if it tells you to simplify the expression, it means we do not want any parentheses or negative exponents. Negative exponents are a way of expressing the multiplicative inverse of a number. However, we are not going to have negative exponents in the final answer. All the exponents will be positive. So let's take a look at the first property, the product of powers, in our concept summary. Again, if you look through the middle column here, you'll notice that all of this is written with a lot of variables. It's very abstract. It may be easier for you to understand what it's talking about if you just look at the concrete examples in the right column. For example, product of powers, it says that if you have p squared times p to the 9th, p squared just means p times p. P to the 9th is p times 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 p. And when we take p squared times p to the 9th, it's the same as just p to the 11th. In other words, we take these powers and we add them together. X to the a times x to the b is the same as x to the a plus b. The way I like to remember it is that I have to go over the multiplication sign here. I'm already multiplying these bases, so I need to add these exponents. Quotient of powers. For example, b to the 6th is b times b times b times b times b times b all over b to the 4th, which is 4 b's multiplied together. Well, remember, if there is a factor on the top and the bottom, they can cancel. And what we're left with is b squared. In other words, when we're going over the division symbol of the bases, we subtract those exponents. Negative exponents. This is where I tend to get a little silly, but it helps me to remember what's happening here. Whenever I see a negative exponent, the very first thing I do is put it over 1. So now I have 3 to the negative 5 over 1. And I like to think of this like a little apartment, if you will. So we have the ground floor and we have the top floor. And 3, if you notice, his exponent, kind of like what's in your head up at the top here of 3, is negative, which means 3 is not happy living upstairs. 3 wants to move downstairs. Maybe he doesn't like taking the stairs. Maybe he just likes being on the ground floor. And when he does that, it becomes a positive 5. The same thing happens if you have a negative exponent living on the ground floor here. Maybe they like the top floor because it has a better view. B moves up to the numerator. There's nothing left behind. You can put it over 1, or you can just simply say b to the 7th. So when you have a negative exponent in the numerator, you want to move that entire base and its exponent to the denominator and make that exponent positive. And it's the reverse. If it's already a negative exponent in the denominator, you move it to the numerator and make it positive. Power to a power. Notice on product of powers, we were taking and going over a multiplication sign. Here, there's no symbol. These two exponents are practically touching one another, And when numbers touch, that means multiply. So power of power just means to multiply those numbers. D squared to the 4th is the same as D to the 2 times 4, or D to the 8th. You just multiply. A way to think of that visually, D squared to the 4th means D squared times D squared times D squared 4 times, which would be D, 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 which gives us 8 Ds. Power of a product. This reminds me a little bit of distributing. When we have an exponent outside of the parentheses, we're going to take that exponent and we are going to apply it to each base inside the parentheses. So if we have the quantity AB cubed, it becomes A cubed B cubed. The power of a quotient is very similar. We're just going to take that exponent and we're going to apply it to every single base, whether it's in the numerator or the denominator. So for instance, x over y, we take that 2, we give it to the x, and we give it to the y, and we end up with x squared over y squared. A over b to a negative exponent, don't worry about it being negative just yet. Let's just apply that property. We give it to the a and the b, which we really need kind of an intermediate step written here. That would be a to the negative 5 over b to the negative 5. But remember, a few steps back, we don't like negative exponents, so the a moves to the denominator and the b moves to the numerator for our final answer. And finally, the one that is so simple that it's tricky, anything raised to the 0 power just equals 1. And so many people mix this up. There's nothing wrong with that, except you want to try to drill it into your head that anything to the 0 power is 1. Anything to the 0 power is 1. Anything in parentheses, x plus 2, the quantity in parentheses to the 0 power is just 1. All right, let's simplify some monomials. Right here, I've created this little checklist, key concept in our notes. If your answer is simplified, you could check each one of these items off the list. You want to make sure there are no power of powers, that each base appears exactly once, that all fractions are in simplest form, and there are no negative exponents. So let's keep that checklist in mind as we go through a couple examples here. There are no powers of powers. Well, in the first problem, there are no powers of powers. Powers of powers would be like what's happening over here in the third example, and we're not over there yet. No powers of powers, check. Each base appears exactly once. Well, I have an A here and an A over here, so it fails. So I know this is not simplified. Let's try to get it simplified. First, I'm going to look at all of these coefficients, and I'm going to multiply them together. 2 times 3 gives me 6. Next, I'm going to look at all of the terms that have a base of A. And these are all just multiplied together. I end up with A to the negative 2 times A to the 3rd. This is one of our properties that we learned above. We're going over the multiplication sign, which means we just need to add these numbers. And when I do negative 2 plus 3, I end up with A to the 1st. I don't even need to put that first power up there because if there is no exponent, it's understood to be 1. Next, I'm going to look at any term that has b for a base. There's just one of them, b squared. And finally, I'm going to look at terms that have c for a base. C to the negative 2. All right, so let's take a look at our checklist. Each base appears exactly once. Good. All fractions are in simplest form. I don't even have any fractions. Good. Uh-oh, there are no negative exponents. I have a negative exponent. That's a problem. But remember, to get rid of a negative exponent, we just take the whole thing. If it's already a fraction, you don't have to worry about making it a fraction, but this is not a fraction, so I make it a fraction by putting it over 1. And now the c to the negative 2 is going to move down and become positive 2. So I end up with 6ab squared over c to the second. That is my final answer. Let's take a look at the next one. Remember, we want to go through our checklist, making sure that we don't have any powers of powers, that each base of, oh, well, we've already failed because I have a q squared and a q to the 7th. Now again, when you're first starting out with problems like this, go ahead and just expand it if it helps. Q, Q, R, 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 over Q, 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 R, R, R. There's nothing wrong with just writing out each piece by expanding it. And then simplify. I have a pair of Q's on the top and bottom twice. And then I'm going to cancel an R, another R, and a third pair of R's. So what do I have left on top? R. And on the bottom, 1, 2, 3, 4, 5 Q's, which I write Q to the 5th. Now it's good to get into the habit of not expanding every time by thinking about, try to visualize 2 Q's on the top and 7 on the bottom, or apply that property. If I do 2 minus 7 because I'm dividing, this is a quotient, I'd end up with Q to the negative 5th, which I'd put in the denominator to make it Q to the 5th. Additionally, I could do R to the 4th minus R to, 4 minus 3 when I'm dividing these, and that would be leaving me with R to the 1st. All right, the next one we have a power of a power. This exponent out here needs to apply to each base, and this is where people make a mistake. I need to give it to the b squared, I need to give it to the a to the 4th, and I also need to apply it to this coefficient. So what I end up actually having is negative 2, put it in parentheses, to the 3rd, a to the 4th to the 3rd over b squared to the 3rd. I've taken that exponent on the outside and applied it to each base. And now I simplify. Negative 2 to the 3rd is simply negative 8. A to the 4th to the 3rd, power to a power. Power of powers means multiply. A to the 12th. And finally, b squared cubed. It helps you to write it out. Write it out for a minute while you're learning and getting used to these new rules. Notice I don't have anything in violation of that checklist, so this ends up being my final answer. Go ahead and pause the video and try these next 2 examples. Alright, I used a lot of colors so that you could see where each piece was coming from. Notice on the first one we multiply the coefficients, we multiply anything with a base of x, we multiply anything with a base of y, and then we simplify and remove negative exponents. In the second example, I showed 2 ways of doing this. You can expand everything and cancel it out, or you can work on the coefficients, then anything with a base of c, and finally everything that has a base of d. Either way, when we remove the negative exponents, we get the same answer. Pause the video and try these next 2. In the example on the left, we have the power of a quotient property, where we're distributing that exponent to each piece inside the parentheses. Same on the right, except this is a power of a product. Let's use what we've learned to solve some problems involving these exponents. Like the first example, we have a monomial times a trinomial because there are 3 terms. 1, 2, 3 terms. And this term, this monomial on the outside, is going to multiply and distribute throughout the parentheses. We're going to keep applying these properties. The first example, I'm going to write more than you might feel like you need to write, but that's okay. After you practice a while, you can start to maybe show a little bit less work. We're taking 3x times 2x squared. Then we're going to take 3x times negative 4x, because that's our second term inside the parentheses. And then finally we're going to take 3x and multiply it by positive 6, because that's our last term. We're distributing the 3x. Now we apply our properties of exponents. 3 times 2 makes 6. X times x squared, remember that's a 1, makes x to the 3rd. Positive 3 times negative 4 makes negative 12. X times x makes x squared. And finally, 3 times 6 makes 18. X. Pause the video and try the second example. Did you end up with 8x to the 4th plus 12x cubed minus 16x squared? Again, we're just distributing a monomial throughout a trinomial. What if we have a binomial times a binomial? Well, some of you may be comfortable using FOIL, first, outer, inner, last. That's perfectly fine. Some of you may be more comfortable with the box method. Either way, you're just going to be applying these properties of exponents as you multiply. Using the box method, I have n minus 9, n plus 7. And now I'm ready to multiply. N times n makes n squared. N times negative 9 makes negative 9n. 7 times n is 7n. And 7 times negative 9 is negative 63. And now I combine terms that are like. 7n and negative 9n are like. So when I try to write my answer, I have n squared. Take away 2n. 7 minus 9 is negative 2n. Negative 63. It's even more important to try to use the box method when we have a trinomial times a binomial. I strongly encourage you to use the box method for this, because it's a great way to keep your terms organized. Notice I'm going to take my trinomial across the top, n squared, 4n, negative 6, n, and 2. And now we multiply and we apply those properties. N to the first times n squared. Add those exponents, you get n cubed. N times 4n makes 4n squared. N times negative 6 gives us negative 6n. 2 times n squared is 2n squared. Remember, when you're coming up with the terms in the box, you're multiplying. 2 times 4 makes 8n. 2 times negative 6 is negative 12. Now we look for like terms. We have an n squared, another box with an n squared. We have an n term, a linear term, and another linear term. So when we combine our like terms, we have n to the 3rd. Now we're adding them. If it helps, go ahead and write it out. Write each term outside the box. Just make a list. because often when people are still looking inside the box, they get the urge to multiply. So it's okay to pull your terms out of the box and then combine your like terms. That helps a lot, so you don't make a mistake. 4 plus 2 makes 6n squared. We're just adding terms now. We're not multiplying. 8 take away 6 gives me 2n. Take away 12. Alright, for the last bit that we're going to look at in this video, we're going to look at a couple of problems that involve our properties of exponents. If we want to write the volume of this prism, we have to do the length times the width times the height. Well, let's start by just taking 7p and multiplying it throughout the first set of parentheses. I end up with 3 times 7, which is 21. P times p is p squared. Negative 4 times 7 is negative 28p. And this third term just drops down, 2p squared. Now I need to distribute again. 2p squared times each term. 2 times 21 gives me 42. P squared times p squared. We add those exponents. P to the 4th. 2 times negative 28 is negative 56. P times p squared is p cubed. So this would be a polynomial that represents the volume of the prism. What about a polynomial that represents the area of this triangle? Well, we know the area of a triangle formula is 1/2 base times height. Substituting, I have 1/2. The base is 2x plus 7, and the height is x minus 5. Again, I need to use the box method or FOIL to multiply these two binomials. And after I do that, I would end up with 2x squared minus 3x plus 2. But since it's the area of a triangle, remember we don't want any fractions that haven't been multiplied or reduced. So we're going to distribute this 1/2 throughout the parentheses. We end up with x squared minus 3/2 x plus 1. Next it says if the area of the triangle is 9 inches squared, what would x equal? So we would need to take this expression set it equal to 9 and solve. But since we haven't gotten to our unit on solving quadratics, rather than review that at this time, as our video has already exceeded about 20 minutes, we are going to leave off with that for today. Please make sure you review some of these example problems and make sure if you have questions to stop back and check with your teacher.